Welcome to the Autodesk Gallery at TED Global 2012. We're going to take a quick walk through our exhibits here today. We're going to start with biocomputation and how that's playing into next generation aerospace. This is work done by David Benjamin from the firm The Living. Started in the Autodesk Idea Studio. What he's looking at is how to use bacteria to create new materials and looking at the interplay between transparency and structure and using computational design to get many variations and then selecting the ones that are optimized for the best performance and aesthetics. He's then working with Airbus to look at the aircraft of the future and looking at how the fuselage may be created from this type of material in the future. Fascinating stuff. Next, we'll move on to similar space using computational design to design buildings. So looking at mass variation, looking at hundreds of thousands of options, many more than a human could ever look at in a similar period of time. Again, looking at performance criteria, coming up with several options and then selecting from those options to get the optimal form and function. And the USC work done by USC, also done in the Autodesk Idea Studio with David Gerber, Professor David Gerber. Next we move on to Bespoke Innovations, and this is personalizing the prosthetic. So this is an amazing story of an industrial designer, Scott Summit, and Bespoke, and what he saw as this emotional liability, where amputees felt really uncomfortable and ashamed almost. And what he did is use 3D printing principles to scan the sound side leg, model that for the other leg by flipping it over, and then 3D printing these amazing personalized prosthetics that really represent the character, the personality of each of his patients. So someone who's a footballer or a soccer player can create something that mimics a football. A woman who is a model wanted this beautiful lace pattern. So really turning that emotional liability into an emotional asset. Next we'll look at Mercedes-Benz and their future concept car, the Biome. This is an amazing concept where they start with seeds, 6 seeds that represent the interior, the exterior, and the 4 wheels are motors. This is created from an external material called biofiber, which will absorb sunlight as its energy source, and its only offshoot is oxygen, the only thing that comes out of it. And as we look over here, we have a mixed reality interface table. This is a table that lets us work very intuitively and interactively to change the scene or change the color. We can very quickly look at different colors by just putting these different markers down. We can move the camera, we can move the vehicle, and we can even change the scenery behind the vehicle. So a great way for designers to work together, work with their clients, and visualize things in real time. The next thing we'll look at is the past, present, and future of product design at Nike. Early inspiration from a waffle iron. Sitting at breakfast with his wife, one of the founders of Nike said, if I took that waffle iron shape and put it on the sole of the shoe, I could have the same amount of traction with less weight. A real innovator. And what Nike does is really looks to own the math of human athletic potential. They are working closely with world-class athletes to understand what equipment will make them perform better. They do a lot of work in their sports research laboratory, doing things like sensors on the soles of the shoe to match, to map the pressure that happens when an athlete is running down the track. And this is a collaboration between Autodesk and Nike, looking at the future of product design, where we can model a human and look at the performance virtually. So this is called the virtual human project or the virtual foot project, and you see how they can take this and really understand things very, very well before they ever go into production. And finally, we'll look at a collaboration between Autodesk and Skylar Tibbetts from MIT and Arthur Olson from the Scripps Institute. This is all about self-assembly. So taking concepts that are found in biology and chemistry and applying them at a much larger scale. We're able to just simply swirl this around and have this object completely self-assemble. And the way this works is with three critical components. There's geometry, there's attraction, and there's energy. And the geometry we have is the shape, the attraction in this case is magnets, and the energy is how hard or soft they shake this. And what that's replicating is the temperature. Higher energy, higher temperature, lower energy, lower temperature. What these researchers are doing are looking at how these principles can be applied at much larger scales to maybe someday create buildings that can build themselves. So that's a whirlwind tour of the Autodesk Gallery at TED Global 2012. Thanks for joining.